So our subject is data engineering, and we will be referring the prescribed book Fundamentals of Data Engineering by Joe Rees and Matt Housley, June 2022 first edition. And today's focus will be on this topic, evolution of data engineer and data engineering versus data science and data engineering skills and activities. But before that, we'll also have a look at the data engineering life cycle. And we also know that before that, we had gone for various definitions of data engineering. And then this was the final definition given by the authors. Data engineering indicates development, implementation, and maintenance of systems and processes that take in raw data and produce high quality, consistent information that supports downstream use cases such as analysis and machine learning. So let us look at the data engineering life cycle. As this diagram can show you, data engineering life cycle has 5 major stages, starting with data generation, storage of data, data ingestion, transformation of data, then serving this data to for analytics, for machine learning, maybe for reverse ETL. So as mentioned here, these are the 5 stages of data engineering: data generation, data storage, data ingestion, data transformation, data serving. Along with that, undercurrents are there. These are the undercurrents: data security, data management, data ops, data architecture, data orchestration, software engineering. So these are the critical ideas across the entire data engineering life cycle. Now, how data engineer evolved? So kind of a history. So if you look at this 2 decades from 1980 to 2000, there was a lot of talk about data warehousing and web. So I remember teaching this subject, data warehousing, for the first time in that era, wherein I spoke about schemas like Snowflake schema, Starflake schema, fact tables and relation tables. And for the first time during data warehouse discussion, big data is huge, that concept has had come. And we had spoken about what is the definition of data being huge at that time. So, data warehouse term was coined by Bill Inman in the year 1989, and parallelly IBM had developed SQL, and Oracle had popularized it. Then Ralph Kimball and Inman came out with data modeling techniques and approaches. So, with data warehousing, scalable analytics, massively parallel processing, usage of multiple CPUs to handle large amount of data. Roles such as BI engineer, ETL developer, data warehouse engineer came into existence. Then we also know that in the 1990s, internet went mainstream. New companies like AOL, Yahoo, Amazon came. .com boom started. Lot of servers, lot of databases, lot of storage, and all the infrastructure was expensive, monolithic, and heavily licensed. So, with early 2000s, the contemporary data engineering took its birth. Companies like Yahoo, Google, Amazon were making noise, but still the nature was traditional monolithic relational databases and data warehouse. And but what happened was they could not give the services to the hugely demanding industry. So there was a need for new generations of systems which were more cost effective, scalable, available, and reliable. With this also what happened, commodity hardware, that is servers, RAMs, disks, flash drives also become cheap and ubiquitous. Uh, Many innovations came which allowed distributed computing, storage on massive computing clusters. Then the era of big data had begun. And what is big data? Extremely large data sets that may be analyzed computationally to reveal patterns, trends, associations, especially relating to human behavior and interaction. But big data is also defined in the form of three V's: velocity, variety, volume, and which extended to five V's also. So Google published in 2003 the paper Google File System. Then in 2004 MapReduce, which is a ultra scalable data processing paradigm. So Apache Hadoop open source came into existence. Uh, then Amazon started its Amazon Web Services. It created elastic computing environments such as Amazon Elastic Compute Cloud (EC2), or simple storage service, that is S3, or Amazon DynamoDB, that is highly scalable NoSQL database. So these that thus Amazon became a popular public cloud. So AWS also created a new model called as pay as you go model. So that made, instead of buying hardware, people simply rented the compute and storage from AWS. So alongside AWS, Google Cloud came, Microsoft Azure came, Digital Ocean came, and many more players came. With the decade 2000 to 2010, big data engineering came into existence. When you speak about big data engineering, we are speaking about big data. When you are speaking about big data, we are speaking about the three V's and the five V's. We are speaking about Hadoop ecosystem, the MapReduce, the Hadoop distributed file system. And in the Hadoop ecosystem, we know there are different tools like Apache Pig, Apache Hive, Dremel, Apache HBase, Apache Storm, Apache Cassandra, Apache Spark, Presto, and many more. So, thus came the role of a big data engineer. And Hadoop ecosystem execution implementation required Hadoop, Yarn, HDFS, and MapReduce. So, big data engineer had to be proficient in Hadoop, Yarn, HDFS, and MapReduce. Uh, it means big data engineers maintain these massive clusters of commodity hardware to deliver data at scale. But what happened was, big data lost its steam because many open source big data tools came which were more simplified, and big data engineers previously had to spend a lot of time, energy, and money on handling all that, whatever they're doing with the clusters of data and specific tasks. So which wasted a lot of money. So now simpler tools, abstract tools came into existence, and now big data engineers are simply called as data engineers, because when we speak about data, it is implicitly big data. With 2020, data engineering life cycle came from Hadoop to Spark to Informatica. We are moving towards decentralized, modularized, managed, and highly abstracted tools. Modern data stack came into existence. Off-the-shelf open source and third-party products made analyst life easier. Now, the data engineer we are speaking about of today, he is a data lifecycle engineer. Okay. So when we speak about data lifecycle engineer, he is kind of maintaining the undercurrents such as security, data management, data operations, data architecture, data orchestration, and data lifecycle management. He is conversant with CCPA and GDPR, which deals with privacy and of the consumers and people. Now, data engineering and data science, always there is a confusion that is data engineering is a subset of data science. But this book and the author feels or says data engineering sits upstream from data science, meaning data engineers provide the input used by data scientists downstream from the data engineering. who will be converting these input into something useful. As you can see here, data engineering is sitting upstream and data science and analytics is sitting downstream. Monica Rogati in 2017 published a hierarchy. Okay, and as you can see the hierarchy here, we'll speak about the hierarchy into two parts, the lower three layers and the upper three layers. If you look at the lower three layers, they are mostly dealing with the foundation of data, like how we are collecting the data through sensors, logging instruments, how we are moving and storing the data through pipelines, ETL, and reliable data flow, how we are transforming, cleaning, detecting anomalies, preparation. So this is data foundation part, the lower three layers of the hierarchy. If they become stronger and companies focus on that, the upper three layers becomes more easier, which deals with AI, deep learning, experimentation, machine learning algorithm, metrics, analytics, and so on. So what is observed is that though data scientists are supposed to do a lot of ML and analysis, they spend most of their time in data gathering, cleaning, data processing, and so on and so forth, and less time on the actual task. So actually, in an ideal world, data scientists should spend most of their time in the upper top layers of the pyramid, that is the three top layers, which is AI, deep learning, A/B testing, experimentation, analytics, metrics, segments, aggregation, features, training data kind of thing. So data engineering straddles the divide between getting data and getting value from the data, while data science drives advanced analytics and machine learning. So what are the skill set of a data engineer? Now the skill set of a data engineer is undercurrents of data engineering, that is security, data management, data operations, data architecture, software engineering. So a data engineer also juggles a lot of complex moving parts and must constantly optimize along the axis of cost, agility, scalability, simplicity, reuse, and interoperability. So with this, we have covered at a higher level evolution of data engineer versus data science, data engineering skills and activities. Thank you.